Welcome, these are the humidity notes. Our objectives for today are to explain relative humidity, describe two ways in which relative humidity can be changed, and explain dew point. First up, humidity is the amount of water vapor that's in the air. Um, Depending on where you live, you'll have different amounts of water vapor in the air. So this picture here, smothered and covered, also refers to humidity in the south. I don't know if any of you guys have ever been to Alabama or Florida. You go outside after you take a shower and you're soaking wet again because we have a high relative humidity there. There's tons of water vapor in the air. When we talk about humidity, we also need to talk about saturation. Saturation is an equilibrium between the number of water vapor molecules leaving the surface and returning back to the surface. So equilibrium meaning the same. So when we have saturation, we'll have the exact same number of water molecules that are evaporating off the surface as those returning to the surface. The amount of water vapor required for saturation depends on the temperature. If you recall when we were talking about density and temperature, at a higher temperature, our molecules spread out and therefore are less dense. So we need more water vapor to fill those spaces to become saturated. Saturated warm air contains more water vapor than saturated cold air. In this picture here, these blocks represent the amount of air present. So at this point right here, we have 100% saturation of water in the air. Air, we describe it as air molecules, even though there's a whole bunch of stuff that makes up the air. And in between these molecules, there's little tiny spaces. So in between all of these little spaces, we have 100% water molecules. It's like a sponge. This sponge would be completely full. As our temperature increases, the air molecules spread apart because they're hot. Thus, we have a higher volume of air, but we're not gaining any more water vapor. So our saturation decreases, 69% here. As we get hotter temperatures, air spreading further apart, 26%, even hotter temperatures, so on and so forth. When we talk about humidity, we're most often talking about relative humidity. So in Colorado, it's very unhumid, it's very dry. So we have a low relative humidity versus someplace like Disneyland in Florida, Disney World, where the relative humidity is very, very high because the air is close to saturated with water molecules. So relative humidity is the ratio of the air's actual water vapor content compared to the amount of water vapor air can hold at a given temperature and pressure. So that's this ratio right here that we were just discussing. So this would be a 100% ratio or completely saturated 100% relative humidity, and we're getting lower amounts of relative humidity because there's more air and the air can hold more water vapor. This is how close the air is to saturation point. So again, here's our air represented by these yellow circles. At 10 degrees Celsius, our air and water vapor are at 100%. The air is holding all the water it can handle. As we heat up in temperature, our air spreads out, so we have more air, but the same amount of water vapor, thus causing relative humidity to decrease. Relative humidity can be changed in two ways. First, we can add or remove water vapor, mainly by evaporation from oceans or other bodies of water. I don't know if any of you have a humidifier in your house, but this is a way to regulate relative humidity within your household. Especially people with allergies and things require that there is more humidity in the air for them to breathe correctly. So they add a humidifier, which basically just evaporates water into the air, so we have a higher relative humidity in our air. This means that if we were to compare two cities, here I have a climatic graph of Denver, Colorado, and Richmond, Virginia. Take a look at this map here real quick. So Denver is right here. And then Richmond, Virginia is over here near the coast. They're about at the same latitude. I think Denver's about 40 and Virginia is about 38 degrees, but pretty much the same latitude of area. We would expect which of these cities, Denver or Richmond, to have a higher relative humidity. Virginia, over here, Richmond, should have a higher relative humidity because it's near the Atlantic Ocean. So water is evaporating off this Atlantic Ocean and affecting the relative humidity of Richmond. Here I've got these two graphs. This is the climatic graph for Denver, Colorado. We're looking for the relative humidity line, which is this gray line right here. So we can see our relative humidity, 43 down to 31 and back up to 40. So we do have some relative humidity here throughout the entire year. Notice that in our hotter months, June and July, where our temperature is increasing, let's see, what's temperature? Red. So in our highest heat months, we have the lowest relative humidity because our air molecules are expanding and we're having a relatively constant probably amount of water in the air. So our relative humidity decreases versus somewhere coastal like Richmond. Here's our graph, climatic graph of Richmond. Again, our relative humidity is by this gray line. They're going to be in the 50s pretty much constantly. So we've got high to low 50s percent of relative humidity for Richmond, Virginia. So the relative humidity for Denver is lower because it's landlocked. We're not near a body of water, so we're not getting that evaporation. While in Richmond, the relative humidity is higher in the 50s because they are getting that evaporation off the Atlantic Ocean. And the second way that our relative humidity can be changed is what we've been emphasizing throughout this. When water vapor content of air remains constant, so we're not adding or removing any water vapor, lowering the air temperature will increase relative humidity, and increasing the air temperature will decrease relative humidity. So here's our relative humidity and temperature graph for a day, starting out at midnight, going back to midnight. At sunrise, when our temperature is very low, we're going to have a high relative humidity. During the daytime, as we heat up in the peak of our day, our relative humidity becomes low. So they kind of mirror each other oppositely. Higher temperature means low relative humidity. Lower temperature means our molecules are squeezing together and pushing and compacting those water vapor molecules inside there, so we'll have a higher relative humidity. Dew point, the next thing we're going to talk about, is the temperature to which a parcel of air would need to be cooled to reach saturation. Again, this saturation is when we have 100% relative humidity. So our air can hold no more water vapor. So we're getting an equilibrium between water vapor evaporating and going back to the surface. If the air is cooled any further past the dew point, it's going to become dew, fog, or clouds. Here's our comic strip about dew point. If the dew point is 51, the water molecules in the air at 53 are almost there. At 52 are really, really close. And then at 51, we're going to get little dew molecules. Our water is going to condense. If we get any cooler than this, we're going to have fog or clouds or something like that. And lastly, today we're going to talk about how we measure humidity. We can use a psychrometer, which is the device we use to measure relative humidity. It's also called a hygrometer. Here's a picture of both of these. In this psychrometer, inside there's two little temperature sticks. One is dry and one is wet. So it'll record the dry temperature and the wet temperature, and then differentiate between the two using a graph, which we'll talk about in class, to find that the relative humidity of this one happens to be 13%. This is the type of psychrometer that we're going to use / make in class. One of these will get coated with gauze and it will be dipped in water. So it will be a wet temperature and a dry temperature, and then we find the difference, and using a graph can find the relative humidity of an area. Again, going back to our objectives today, you should be able to explain relative humidity, describe the two ways in which relative humidity can be changed, and explain dew point.